We're back. I want to get a sense of if these forks are long enough to counter the torque on spin-off. This weapon is the highest moment of inertia of all of my weapon options that I have, so if it doesn't tip forward with this one, it won't tip forward with the cutter blade either. Well, I guess it tips forward.
Hey there, this is Seth Safer from Team Just Cause Robotics, and today I want to give you guys an early look at the design that I have so far for Division, my 3-pound Beetleweight robot. I'm working on a full redesign for a version 3.0, after having made about a dozen versions prior to this, and made small improvements along the way. I think that I've pigeonholed myself with all of the little improvements that I've made while sticking with the same basic design, so by starting over from scratch, I should have complete freedom to do everything correctly this time. At least, I hope so, anyway. Hope you've cleared your calendar, because this is going to be a very long video.
Forgive the sniffles and coughing, as I still am getting over my cold a little bit. This is basically the main element of what will make up Division version 3.0. This red plastic part will be aluminum. This red plastic part will be aluminum. This pulley and this hub here will be plastic, but they will probably be reprinted in nylon. Right now they're just in PETG. All of this is PETG for prototyping purposes because it's one of the cheapest plastics that I can get and print with nicely. You'll actually see that I am printing a 3D printing commission of a couple Antweight chassis right now for somebody else in PETG. It just prints really, really nicely, and it's one of the faster materials to print as well. Anyway, so this is the main body that will make up Division V3. The idea behind this redesign is to make the bot serviceable quickly and easily, and reduce the number of screws that need to be removed to replace critical components, not just by reducing the number of screws that hold on a critical component, but by reducing the number of other things that need to be removed in order to access the screws to get to that part. So for instance, to get access to these screws for this side here, if I use a low profile right angle wrench, I might be able to get in here with only removing the top plate. But I also could just remove like 5 screws from the bottom to remove the drive pod out of here, which looks like, well, right now it looks like this. So it'll be like 5 screws on the bottom holding that on. And then I can do this comes out, and then I can access these screws up in here to get access to that. And there's going to be a bunch of screws here, but I don't necessarily need to use all of them. I just wanted there to be a little overkill holding the uprights in place, because this is one of the most highly loaded, or probably the most highly loaded part in the entire frame. You'll notice this looks like there's a lot of material missing here. That's because there is a plate that will take up some of that space on the motor side. This plate will be either titanium or aluminum. I'm thinking probably aluminum will be fine, and that should help to heat sink heat away from the motor and bring it into this upright, which then will dissipate through the entire frame, as well as helping to support the motor and make it so that it can be changed out really easily by just chucking in a screwdriver out here. And I can access these 4 screws to take it off much more easily than I could previously, accessing screws for face mounting the motor inside the upright. As you can imagine, I can access like one of those and maybe this one, but there's like no way that I'd be able to access all 4 through the frame while it's assembled. So by doing it this way, I can swap out the motor with just 4 screws. I can just have a second motor already mounted to another mount plate if I need it, and should be good. The belt pulley setup is one other major change from version 2. And this motor is the same size as will be on version 3 and was on version 2. I just haven't bought more Cobra motors since I destroyed the ones that I had. This is what's left of one that fought at sword. As you can see, it may have been directly hit by a couple robots and is a bit worse for wear, but it's the same physical dimensions as this prop drive 3536. This is a Cobra 2814. They go by stator size at Cobra, whereas this is the can size. So it's 35 millimeter diameter, 36 millimeter-ish long can, and it has a 5 millimeter shaft, just like this prop drive does. I'm just using a pulley that you can buy on Amazon that's meant for stepper motors with 5 millimeter shafts, and it's for an XL belt. The previous version, I used an S3M belt. You can see the teeth are a lot smaller. Let me grab another pulley example, actually. So this is the pulley that I have on the motor right now. This is a 15 tooth XL pulley. You can put these on CNC machines, 3D printers, whatever. But the teeth are spaced about 5 millimeters apart instead of about 3 millimeters, instead of exactly 3 millimeters apart on this. So the physical teeth are larger, the grooves are deeper. That should mean that it should be less sensitive to how well tensioned the belt is in terms of it slipping, which I think was the problem that I was running into at sword that prevented me from being able to self-right consistently. You can see this belt is also positioned such that it should be tensioned basically perfectly already. So I should have no problems with the belt tension loosening or anything because this motor can't really shift around any. There's flathead screws in the motor plate to make it so that the motor can't shift within that plate. And then I'm just using button heads here because that way they're larger heads and I can easily access them. But I could theoretically switch these to flatheads as well just to make it so that the position is more locked in, because a clearance hole always has a little bit of slop to it. But, you know, it is what it is. I think this will work out quite nicely in practice. And I think as long as this plate is reasonably rigid, there should be no reason that I ever lose belt tension. So these are earlier versions that I printed of those two components. So I have the pulley here, has my version 1 weapon / logo pattern in it, and then this is just literally an 8-screw hub. I think I'm probably only going to use 4 of the screws ever, but I always have 8 screws in. I've always had 8 screws. I only have 2 of them in right now, actually, because this isn't going to hit something, so I don't need to transfer so much shear load, but you get the idea. So basically, there's a stack up that happens with the weapon sandwiched in between. This weapon stack is one of the most important parts of the design because it determines how nicely the weapon runs, and that determines how much load there is on the weapon motor. And it can also have a huge impact on how well the belt tension is maintained and what kind of tensioning is needed. If I were to use a smooth pulley, then I would need a lot more consistent tension than using tooth pulleys on both sides. So the idea here is weapons in the middle. On the motor side, we slap a pulley. That pulley obviously is what transmits torque between the motor and the weapon. So I need some way of transferring torque between the pulley and the weapon, which is why I have nice long screws that kind of act like a shear pin that hold the two together. And then on this side, which is new for this version, I added another spacer thing here. You'll notice there is a big gap between where the weapon is and where the pulley teeth begin. That's also a change from the last version. Here is Division version 2.12. You'll notice one big change here is how wide the entire weapon stack actually is. So hopefully you can tell version 2.12 versus version 3. The weapon stack up width is extremely different. So this pulley has a much bigger amount of non-toothed area between the weapon and where the belt sits. And then similarly on the opposite side, we also have this big hub as a spacer to prevent the weapon from scraping on the uprights, which you can see right now with the uprights slightly bent as they are on version 2.12 is a major problem because the weapon's literally cutting through the upright already. You can see it machined out some of the material there. Let me get my light here. Literally machined through itself and started cutting away all that black paint and some of the metal underneath it. So obviously this is very bad. And do you see how close that pulley gets to the weapon as well? That is horrible. This is why I keep losing motors. It's because the weapon just is able to flex a little too much. There's a little too much play here, and I can't quite remove all of that play. Some of it just comes from the bores in these uprights rounding out or ovaling out over time from all the repeated impacts that this experiences. So the blade can kind of bend over, and this pulley, because it has a clamping hub, you can see it's like a split hub that's supposed to clamp together with this screw here. Those don't work very well. So what happens is these kind of slide their way down the shaft until they get into the path of the weapon hits them. And that's why the motors get ripped off, because the motor's got M3 screws holding it on, and there's into aluminum part. The motor front end of the can is aluminum. So the steel screw threads just rip through the aluminum, pull all the aluminum threads out, and then the motor goes flying. To prevent that, quite simply, what I've done is add more space everywhere. So this weapon stack is, I believe, 1 inch, whereas this weapon stack is 1.5 inches. So I went from using 1.5 inch shoulder bolt to a 2-inch shoulder bolt. Both are 3/8 inch diameter. I'm using the same bearings because they worked so well. There are 2 bearings that are inside of where the weapon is, and then a third that is inside of the pulley on the far end to support it. So inside of here, there's a bearing that is protruding halfway out of this basically. So half of that bearing is on this side. Then there's a second bearing, half of that bearing is on this side. Then the other half is encapsulated in this pulley, boom. And then a third bearing gets stuck on in here so that it's just on the very end of this pulley. That third pulley, or that third bearing takes very little of the load, but it just kind of keeps everything constrained so that since I have bearings as far out as possible on each end of the stack, the ability for the weapon to wobble like this on the shaft is reduced. Not that that was really the biggest component before, because really I think it's just the shaft wobbling inside the holes in the uprights. One thing that I've considered doing, but haven't made provisions for, is instead of having the hole in the upright be a 3/8 inch hole in an aluminum part, and then the steel shaft goes through it, I might at some point, if I keep finding that those holes are enlarging after many hits, make it so that the hole is like a 1/2 inch, and then put a steel 1/2 inch to 3/8 inch adapter that sticks out a bit on the ends here, and then use an even longer shaft. But I don't feel like it should be totally necessary to do that just yet. So I think I'm gonna stick with it as is for the moment. And I think that because there's so much more room for this to be able to flex without hitting itself now, I should easily be able to get away with there still being a little slop there without it totally killing me. On top of that, the fact that the teeth onto the belt pulleys sink way deeper means that this vertical center to center distance between the motor and the pulley doesn't have to be nearly as exact in order for this to maintain the ability to drive the weapon. The whole point of Division is that it has just a ridiculously powerful weapon, and I don't want to dedicate any weight that could be in the weapon to anything else. So the weapon is the way that it self-rights. If it gets stuck on its face, it literally needs to be able to do that to self-right, and it has in the past. And if it's stuck on its back, I need to be able to hit here to bounce myself back up. Or I can maybe do this to bounce myself back upright. One thing I haven't figured out yet for this version is how to prop up the back. You'll see on version 2 and version 2.0 through 2.12, I have it so that the blade just barely hits the floor in the back here when it's propped up, because I have these little triangular protrusions on the sides. I'll probably just make some sort of a bent metal part that bolts straight onto the back that does that, because the reason I don't want to make that part of the back is that this is being milled out of a solid block of aluminum, and that block of aluminum is going to be exactly this long, so that I don't have to buy more expensive aluminum just to mill away like 99% of it at the back here. So having just a little bent like titanium or even aluminum fin that sticks out the back, I could just replace that fin without having to replace the entire expensive billet part if it gets broken off, and it'll be light and strong, so that won't be a problem. These fins are titanium, which is more dense than aluminum. The way that material densities line up, you've got steel, which is the most dense material that I'll use. Brass is 3% more dense than steel, but it's like basically the same. You got steel at the highest density. Then you've got aluminum, which is about 1/3 of the density of steel. You've got titanium, like I used for the side armor here, that is half the density of steel, so a little more dense than aluminum. And then you've got plastic, which is about 1/3 the density of aluminum, about 9 times less dense than steel. So these big bulky parts here, like this pulley, would be ridiculously heavy if they were made out of aluminum. That is a 21.9 gram pulley in a PETG, and it's hollow inside because it's 3D printed, which is the other nice thing about 3D printing. This isn't even as heavy as if it was made out of solid machined plastic block. Then I've got here an aluminum pulley, same exact tooth count, boop. These are about the same. This is actually shorter, but obviously there's a bit more material around the hub area. It literally is 5 times as heavy because this is hollow inside and the plastic is 3 times less dense than the aluminum this is made of. This is not a necessary place to put all of that weight. If we're talking ounces, this is 3.7 ounces versus 0.7 ounces. That is massive. 3 ounces out of 48, what does that add up to? So that would mean just this pulley is almost 8% of the weight of my entire robot. But instead, in plastic, that pulley is 1.4% of the weight of my robot. Meanwhile, because this is division, the weapons are like 9-10 ounces, and they make up the bulk of the weight of the spinning mass by far, so that I can just deliver all of that kinetic energy to my opponents. And the weight is in the steel out here, so that I have more moment of inertia on the weapon, which means that it hits harder and stores more kinetic energy in the blade. This blade here actually is my heaviest, or not my heaviest, but it's the highest moment of inertia because so much more of the mass is on the outsides due to this long ring counterweight, which obviously is substantially bigger than the one on here. And this big tooth out here with relatively thin spokes everywhere. This weapon is not necessarily made to take huge horizontal spinner hits. This one is, and this one, the upright's completely crumpled. You can see while using, I don't think it was this exact blade, but one just like this. Horizontal spinner hit here, it completely twisted the uprights, which are aluminum, but this steel blade was fine, didn't bend at all. Unfortunately, that cannot be said about all of my blades. Like I said, version 1 of Division used a blade that looked like my logo. That was what my logo was based off of. This one was fighting a robot called Scrambles TDD at Sword back in 2019. Shit's not straight anymore, bro. Big horizontal spinner. Came in, hit this so hard, you can see this is an AR-500 steel. This is literally what shooting targets are made out of. This steel is so hard. That tooth is gone. It carved through it at like a 50-degree angle just from the energy of that hit, and the entire blade bent. So this is unusable now. It bent over so much that it practically hits the pulley every time it comes around. So there's just no way that I was willing to keep using this weapon design against horizontal spinners after seeing that. I might bring it back against a vertical spinner, or just because it's fucking cool. And because it makes self-righting a little easier, because it can only go back so far, and it can only go forward so far. Whereas with this blade, obviously it can go to here. With this one, I only have to bounce from here up to like there. So it makes self-righting a little bit easier, but I have enough torque that my bot can literally like do this. So I'm not terribly concerned about that. The way that I used to mount my front wedges, I used mounts that were not identical on both sides, which is kind of a pain. I had to mirror the part and print a mirrored version of it. In order to reduce the number of unique parts that I need to bring in for fights, I've decided to try and make the mounts completely identical. So these can literally just be interchanged left and right, right and left. Doesn't matter, they're the same, which is why you'll see I have these like fork mount points on both sides of both of them. This I accidentally designed wrong, so the holes are too big on this side, but you get the idea. If I actually mirror my part in Fusion properly, that won't be a problem. Oh, I did forget that there is a little fillet there that needs to be addressed. Oops. But yeah, basically the idea is these can bolt on like so. And then I just printed these in TPU, so they're super floppy, but the real version of this will be titanium. These go on like that. And like that. Kind of completes the front horizontal spinner setup look. So I think that'll work quite nicely to deflect spinners away from the wheels. The wheels stick out kind of far because they're really wide wheels. But that kind of gives you the idea. And obviously I could potentially make different versions of this. This one, I basically like had it so that this bend happened like right at the edge of the mount at first. I had it so the bend was like there. I just extended it a ½ inch to get this. So I could potentially make versions of these that are lighter and they have the wedges a bit closer, or the wedge like stick out a little closer. Or I could even make a version that maybe has 2 bends, and the second bend could even wrap around to like all the way up to here or something. I don't know. That's something I have to play around with still. And I'm still not 100% sure on the weight for this. One thing I still haven't figured out exactly is the top armor. I still don't know exactly how I want to mount it, per se. Originally I wanted to try and get mount points in the billet, but it would have been kind of a pain in the ass to machine it that way. So the way I've planned it out would basically be I have a threaded insert here, 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 and here. But I would like to have 4 screws on each side. At first, that was what I was thinking I would need to do. And especially because the weapon kind of cuts through the back of the bot. Otherwise, I would be like, oh, I'll just do one top panel that spans the whole back. But no, you can't really do that because the weapon needs to hit low. You'll also see I cut through the bottom of the bot, not because the weapon would actually do that, but because it gets within 1/8 of an inch, and that's as close as I'm comfortable with. So this version of Division is hitting with the weapon 1/8 inch lower. Oh, and also it's way more forward than it used to be. This Division, I have the wheels a ½ inch back from the center of the chassis here. So this is 4 inches. The wheels are shifted back only a ½ inch off of that 2-inch center line, and the weapon is dead on that center line. Here, I believe I shifted the weapon 3/4 of an inch or a full inch from the, or 3/4 of an inch from the center line, which is about here. And the wheels are also shifted back by more than that. And I actually have two positions where I can put these. So I can put them there or there. So they can either be like all the way forward or shifted back a 1/2 inch. So there the wheel comes just about to where the back is. And then here it's just up here. So this is still the wheels further back than before, I think. And then this is like extra far back. I think that the closer the wheels are to the center of gravity, the less lifting up it'll do when it turns. And the less of like a, you see this oftentimes with vertical spinners where it'll be driving around and then you'll start to turn and you'll notice it gyros and it always kind of like wanes backwards a little bit. The amount that it kind of coasts backwards on a turn seems to me to be very much tied to just how far forward the weapon axle is from the center of mass of the bot. So on a bot like crossbow, where the bot's like this, you'll see it like goes in this like massive arc, whereas with Division, at least with this version of Division, it does it more like...
Fight, robots, fight! Ooh, big hit from Division.
Wow. So these two bots saw each other back in May.
Forward, I think, is good, but the really important aspect of having the weapon further forward is just how much lower that the bot actually hits another robot. So look how high off the floor the blade is. If this is like basically the floor, look how high off of the floor that blade is hitting. Compared to with this, it should be like something like a 1/4 inch lower. That's kind of hard to see, but it should be a lot lower to the point where I'm actually crossing that threshold where my wedge is. And I think that'll make it a lot easier for me to hit other smaller diameter vertical spinners, which previously the bot kind of just whiffs over, especially if they have a wedge on the front too. So if it's like, if I'm going like front wedge to front wedge, I want to be able to catch that part of their wedge and actually do something to them. Whereas with this, it'll probably miss them entirely, which is not so good. So that's a huge improvement, I think, to being able to fight like more normal shaped robots. Wow, this is already like 1/2 an hour long and I have barely done anything except just show you this and talk. So let me start. I'll probably have been interspersing clips of this thing actually fighting this whole time. Hopefully this wasn't too terribly boring with just me talking and showing this model on camera, even though it's not able to drive around yet. But I promised my next video about this, I'll have it driving and spinning, and hopefully I'll even have a metal version of this chassis. And I will also have a custom PCB that I've designed for this guy that'll distribute power through the back. That's why there's this gap here at the back, instead of this being merged with this wall, is simply so I can run the power through here, because there's a little clearance there, if you can't tell. I'm gonna be using a good portion of that clearance, so the PCB will just come up to this lower level here, so the weapon can't hit it. It should be about 0.18 inches away passing it, so it doesn't cut its own power wires in half. That was one of the major things that I thought was terrible about this version. The power wires are literally running underneath the robot, so this is literally how it is like in combat. I have the signal wires, so I have like under this top half the battery sits, and then this is where the power for the battery goes in, and then this is where power for the drive speed controller for this drive motor comes from. And then I pass that, and then I pass the receiver cable for this drive speed controller underneath the robot, through this hole, through that hole, into this half. And then in this half, you can see I designed, this was one of those things where it's like a holdover from the previous version. The motor wasn't like in the same place, and now it's like really hard to access the screw. This is the main reason I'm doing a ground up redesign for V3 is just, there's so many things like this, where it's like, I pigeonholed myself with version 2.0, and then I didn't change the base plate at all from version 2.0 to 2.12. And so there's so many things that I just live with that are terrible, simply because I can't change them without buying like a whole new set of parts. So I'm now caving and spending the like $1,000+ to get a whole new set of parts for version 3. So that I don't have to live with all of my past mistakes. So this is version 2's layout. We've got a battery. It goes here, plugs in right there, tucks right in there. And then I can turn on the robot with this finger tech switch. That sends power underneath the bot to this, and then that goes to this big plug for this weapon speed controller, and to this small plug here that goes to this drive speed controller, which is packed, I have removed from the bot right now. Then there's another plug that goes to this BEC here that sends 5-volt power to the receiver. This cable is the signal wire for the weapon speed controller going to the receiver. And then I've pulled out the drive speed controllers because I wasn't driving the bot in my last video when I was showing how the weapon spun. So basically, ordinarily you'd have a drive speed controller tucked in here and another drive speed controller tucked over here. And those have signal wires that need to go to the receiver. So the one on this side, that signal has to run underneath the robot, which is horrible. And I lost one fight against Tiny Huge because he actually hit through here while the bot was upside down, and it cut that signal wire for the drive side. So I lost both drive sides because one of them physically broke, and the other one I just lost signal connection. So to address that, this PCB that I've designed for version 3 will have 3 traces, 2 super wide traces to handle the ground and the power, and then a third tiny trace to handle that signal wire. Because it references the same ground, I don't need a signal ground and a ground. So there will be 2 super thick traces on the bottom, and then 1 tiny signal trace at the top, which I realize now may be a mistake, but I don't think the weapon will ever hit them. If it did, it will cut that signal trace first, which kind of sucks, but the rest of the robot will still have power, so that's probably better anyway. And it will have a switch integrated into it. This hole is not in the right place, but it'll have the same switch that I have on my PCB switch and my AAO board. So this is a screw style switch that uses a press nut that goes into the board, and then you just solder around here and it makes a really, really solid electrical connection. That's broken with a simple turn of a hex wrench. Same exact hex wrench you use on the FingerTech switches. You just unscrew it to turn it off, screw it down so that the head contacts the board to turn it on. And this can easily handle well over 30 amps. This is a 1 ounce copper board, which means the copper layer thickness on this board is 1 ounce per square foot, I think. It's some really stupid esoteric thing, how PCBs are defined. Don't ask me why. But anyway, the version that I will be running in Division is a 2 ounce board. So it'll have twice the copper layer thickness, and the traces will be super wide because the whole thing is going to be like basically the same height as this switch anyway. So I'm just running 2 power lines on both sides of the board, top and bottom, whereas this one has the power running through the top on one side and to the bottom on the other because it's split via the switch. So it'll basically have like 4 times the current handling capability of this. So running like the 50 amps to run the weapon motor will be no problem. So otherwise it'll be very similar to this. This fingertech switch will be replaced with one of these screw switches. I'll just access it through a hole in the back of the bot. So that'll be like there-ish. And then I'll just have XT30 for the battery, XT30 for the drive, a 3-pin connector for that receiver signal. That'll jump through the PCB over to this side, where I'll have XT30 for the weapon, XT30 for the drive, that signal breakout with a 3-pin servo connection, which will just be a jumper wire to the receiver, and then a 2-pin to power the BEC, which is going to still be external just because it is easier that way. The BEC that I use right now is just one of these guys off Amazon. I got 2 of these for like 12 bucks, I think. And these have worked extremely well for me in the past, and they're super reliable, so I'm just not going to change it. That's actually what is currently wrapped in tape right here in Division V2.12 already. That red connection right there, that is the BEC output. So yeah. All right, well, this video is now super long, but hopefully covers literally everything that you would ever need to know that I've made progress on for version 3. And hopefully it's not the most boring thing you've ever seen, despite the fact that it's mostly just me talking, and I'll try and intersperse some fun spin-up videos to make it slightly less painful to watch. Alrighty. That's all I've got for you today. If you like this video, click like. If you want to see more videos like this, make sure to subscribe and hit the bell icon. And as always, thanks for watching.